So now, would you like, if anybody has a presentation, Karim, would you like to? Yes. So Karim Chine was, well, he was actually a reviewer of the Chain project, the previous version of this current project. He was a reviewer, and he was very friendly and quite constructive actually in his comments. And he's actually working on different, some new ideas about the cloud, specifically in terms of providing a virtual research environment type of thing. So you will talk about this also. Right.
So I'm pleased to be here with you today. I think it's fortunate that my presentation follows the one given by Roberto. You will get a kind of two different views on something quite important for the use of e-infrastructure by the vast majority of researchers. So Roberto, in a way, represents the orthodoxy in matter of science gateways, and I'll be giving the view of a kind of schism in this domain. Basically, what I will show you today is really radical new ways to make the infrastructure work for the people who needs it, the long tail scientists and everyone in academia. I will start by an introduction, then I talk about Elastic R and how it could solve some of the problems that are still pending. I will show you probably a live demo for 5 minutes, and then I will conclude. So as an introduction, the first part of it actually has a lot of echo with what Roberto showed you. We are kind of shifting to another paradigm in scientific discovery. Now we enter the age of data-intensive science. That age required new tools, and those new tools were built within the arena of e-research. After years of work and investments, many people are looking at what has been the outcome of this work and consider that some of what has been produced actually look like dancing bears. The bear is a metaphor for, I would say, for the grid and a variety of things that actually remain tools for a very, very specific type of scientists, those who are really fully IT literate. So the bear is really a terrible dancer, and the wonder isn't that the bear dances well, but that the bear dances at all. It became urgent, actually, because we are witnessing the rise of data science and the emergency of big data as a kind of hot problem to tackle and to deal with, not only in the scientific arena, but beyond. Basically, let's say, our civilization is becoming a data-centric civilization, and the tools for dealing with these challenges are still missing. The starting point should be the tools that people use on a daily basis. We need to take what they currently consider as their productive environments and put it on the infrastructure, and not just build infrastructure and get those tools somehow to integrate with it. Those tools are called R, are called Scilab, MATLAB. The target really is to do in the data science arena what people did in electronics. You can go to the shop and buy something called Arduino or Raspberry Pi. These are very cheap toolkits that allow anyone to build very sophisticated systems by plugging together capabilities. Really, a child could do it. The idea is to say, can we do that for the data science arena? Can we make the creation of science gateways easy enough for people to do it on their own? So that's what we are trying really to achieve. And one of the technological capabilities that became available is cloud computing. It's not only about having, for cheap, impressive resources, storage, and compute capabilities. It's also having, for the first time, something that would work like the 3D printer for services and applications. So basically, thanks to virtualization, thanks to all what the cloud offers, we can get models of science gateways or various capabilities that people use in interacting with data, in doing analytics on data, and make them shareable the way you would share a 3D model on Facebook, so that your peer collaborators can reproduce the physical object. Here, what people would be able to reproduce is the service, is the capability for processing data and producing results that would be published or would be just used for further research. In order for this to happen, the cloud is not enough. We need to put on top of the cloud a platform where the artifacts of computational science become pluggable the way you plug your mouse or you plug any device to your computer. So basically, we need to define new contracts. I think the existing standards are not enough. Those contracts actually, in the case of Elastic R, this platform I will show you in a minute, rely on a metaphor. Basically, what we need to build is something like a robot for data science that we can create on any infrastructure and that people take control over in a stateful way. Basically, you will say where your data is, you will say what capabilities your robot should have, and send it where the big data lives in order to achieve whatever you need to achieve, looking at your data, sharing, producing whatever artifacts your computational research requires. Once we have defined those robots, we can make them collaborative on real time. So basically, two researchers in two places over the globe could be interacting with the same robot, looking at the same session at the same time, the Google Docs way, but here while working with data and doing data analysis. Of course, where this can happen, it could be Amazon's cloud, the most obvious place for it, but it could be anywhere. Anywhere could be a private cloud, could be Microsoft's cloud, could be anything that can run a process and make it accessible remotely. And of course, if we achieve this, reproducible research becomes within rich in a way. Reproducible research, basically, if you imagine scientists sending some work to Nature, claiming that some results have been produced on top of some genomic data. The reviewer from Nature is not able really to do exactly what the scientist did because the scientist relied on a variety of tools and environment and capabilities that are not easily accessible to the reviewer. Imagine that this happens on a cloud and that the scientist is able to share the description of the artifacts that the reviewer can connect together to get exactly what the scientist used to produce those results. Then we have a way, really, to get the interaction and the validation of the work that has been done easier than ever. That relies, of course, on the virtualization that lives on the clouds, but it requires also software capabilities such as the idea of the data science engine or data science robot that I showed you earlier. And of course, once the reviewer is happy with the results and they are published, we can put in the paper the identification of the artifacts that have been used so that everyone later on, after reading the paper, can just go and start from where the authors left. And that's really the idea of creating the ecosystem of science. And also this idea has some echoes with the idea of the marketplace Roberto presented earlier today. What we need to build actually is just capabilities that put the focus not on machines, compute, storage, but put the focus on what people really use daily, such as R, Python, IPython, whatever tools they have commonly and currently used to make the research and to deal with their data. So let me switch to a quick demo. So in the browser, I'm here. Let me just refresh. So basically here I am accessing a portal. And this portal contains an application that orchestrates all these capabilities and takes care of the life cycle of what I told you earlier about the data science robots. So what you see here, just let me scroll down. You see here, first of all, something that allows anyone to describe the need. The need is, for example, doing statistics using R or doing some numerical simulation using Python. Once the capabilities required are described, the system exposes what is available on a particular cloud. For example, if you would like to tackle a problem that requires plenty of memory with R, then you will pick, for example, this machine. This is a machine with 32 cores and 244 gigabit of RAM and costs $3 per hour. Nobody could afford buying such a machine. It's available to anyone, anywhere, just in one click, okay? So once you have defined what you need, you would say where your data is living, and you would push a button after giving your credential to that particular cloud. And that's all you need. So here we created the data science robot or data science engine somewhere in the US. We can be specific on the location. So the system is launching, and here I have already created one just before the demo. By creating that engine, I have something here that looks like a virtual board for services, where I can take any tools I want and make them available as widgets that I could share later with my collaborators. For example, what kind of widgets I could ask for. Here I am asking for a console that would allow me to interact with any tool that people commonly use in data science. Here I'm talking to R. I'm asking R to show me the variables. No variable is available. I'm defining one as being 880 element of the normal distribution, and I am drawing the histogram of X. So this is a kind of stateful interaction with that robot that lives somewhere in the US and that looks to my data. So this is the histogram coming there. I'm switching to another sheet where I will be using, for example, RStudio, which is a very kind of popular tool for working with R. I can use, likewise, I could be using IPython. I could be using VNC, so this is RStudio here as a widget, not as a portlet, something that I created in one click that I could create programmatically. I could be here using just VNC. Basically, I am controlling via remote desktoping the machine I have in the US. So all this operates on the data that I have attached to that particular machine. That data could be anywhere, could be on my Dropbox folder, could be on my S3 storage, could be anywhere. This is, yeah. So here we go. So the idea of this, this platform is to say we have a way to deal with data science without developers. So that's the key point of what I'm showing you. If you would like scientists to use infrastructure, we need to remove all kind of friction from their way. And having to interact with developers is a friction. Having to interact with administrators is a friction. We need just to make it self-service and get them to create what they need and interact the way they want and share anything, either on a synchronous or in an asynchronous way, basically have some real-time interaction if they want, or just create artifacts and make them available to others. Just to show you the integration of the scientific artifacts, what you see here is a widget. This widget is a spreadsheet like Excel. This widget integrates capabilities that computational chemists use. What capabilities are here? For example, in the cell A1, I have described a molecule, a compound using the SMILES protocol. So basically this says I have 4 carbons or 5 carbons. In the cell B1, I have a function that is a wrapper of a tool that takes the description of the molecule and gives me the 2D representation. Just by putting this in cell B1, it becomes a result, visual result that is returned to the cell. Of course, if I change here the description of the molecule, by saying it's, I will add some carbons. The result is that this function is computed again on the cloud and have the 2D representation. And in this cell, I have the same thing, but with an entire application, which is called JMOL, used also by computational chemists. Here we have made those tools like widgets that people access with simple functions, with simple drag and drop. So basically, I think as you said yesterday in a discussion at lunchtime, the holy grail is really to get scientists do and access infrastructure by themselves, produce things and share them their way, and try to get the IT involvement as limited as possible. What I showed you is actually one way to do it, but I think it's the direction we need to take in order to make VE infrastructure becomes a daily tool for the vast majority of the people we care about, that is scientists. Yeah, so I will stop here to leave some room for discussion. Thank you very much for your attention.